Hello once again, ladies and gentlemen. Welcome back to the 2000 Pascal paper. That's the grade 9 level contest. And we're on to question number 24. It'll be this question, and then we have one more to go, and then this contest paper is done. So, question 24 says there are 7 points on a piece of paper. Exactly 4 of these points are on a straight line. No other line contains more than 2 of these points. 2 of these 7 points, okay. 3 of these 7 points are selected to form the vertices of a triangle. How many triangles are possible? Alright, so we have 4 points on a straight line and then 3 elsewhere. How about we just draw those? So we have 4 points, which I will do my best to keep in a straight line. The problem is if I sort of jumble this about, it keeps asking me if I want to change color. And I will change color for the other 3 points. One here, one here, one here. And that way we have no extra lines formed. No other 3 are collinear. And since I already have black and let's touch these up with red. So the red are my collinear points, and the blue are my non-collinear points. Now, we can't form a triangle with 3 points in the same line, so 3 collinear points. And from there, we see at least 1 blue point must be used. So we have these things nicely separated into the red points and the blue points. And we're trying to make triangles here. So we could either use 1 blue point and 2 of the reddish pink stuff, 2 blue, or all 3 blue. 1 red and 0 red. As I said before, we can't have 3 red. Those would all line a straight line, and we'd have not a triangle. It would basically just be a flat line segment, basically. Well, not basically, exactly that. Okay, so if we could use 1 of the 3 blue points, we have We have 3 choices for 1 of the blue points. And then we have 4 options, and we need to choose out 2 of them. So I'm using binomial notation or choose notation. If you have 4 things and you choose 2 of them, this is the notation to express that. And we have 4 different red points that we can choose, and we need 2 red points. 1 blue, 2 reds. Okay, for those of you who don't know, we'll just write it off to the side. I'll write it up here in the corner. N factorial over k factorial n minus 1, or n minus k factorial. That's the number of ways to choose k things from n things. Okay, just in case you're not familiar with that, not everyone in grade 9 is, and certainly they don't cover that in the curriculum. But that sort of stuff does come up. And if you had a problem with that, I suppose you could always just label these points A, B, C, D, and write out all the possibilities. There's going to be 6. You could choose A and B, you could choose A and C, A and D, B and C, B and D, or C and D. And we have 3 choices for the blue, which we'll, I guess, label X, Y, and Z. Okay, so that means that we have 3 times 6 equals 18 possible 1 blue, 2 red triangles. Alright, now if we had 2 blue, one red triangle. So we're picking 2 of X, Y, and Z. We're picking 2 blue points for our triangle and just 1 of the red points. Alright, so we once again have 3 choices. Basically, it's which one are we going to choose to not be part of the triangle. And so we could write this as 3 choose 2. But there's no point. There's no need to. I mean, I'm regretting putting this 4 choose 2 up here if I could have just listed them out. Because I'm trying to write this maybe the way some of you will, and not everyone in grade 9 who's writing the Pascal is aware of choose notation. So that's me doing a little overkill on the problem. So we have 3 choices for which blues we can choose. We could have XY, XZ, or YZ. So I think from now I'll just list the choices out. And we have 4 choices for the one red vertex that we're going to choose. The one amongst these 4 red that we're going to choose. So we could take X and Z and C, and we could form a triangle that way. Because we're asked how many different triangles we can form here. So we have 18 choices for the first case, we have 12 choices for the second case, and to choose all 3 blues, we'd have to choose all of X, Y, and Z. So there's one way to do that. So we have 18 ways to make a triangle with a blue and 2 reds. We have 12 ways to make a triangle with 2 blues and 1 red. And then we cannot forget this last case where we use all 3 of the non-collinear points, which in our diagram is labeled as blue. So we get a final answer 31, and I hope 31 is one of the possibilities. 18, 23, 30, 31, 33. Okay, so I think the answer is D, but let's just double check. We haven't missed a case here. Alright. So there's definitely only one way to use all 3 of the non-collinear points. Alright, that's clear. We can't use all 3 we can't have all 3 of our vertices of the triangle be collinear. There are 4 of those. So that's out. 1 blue, 2 red. Yeah, you're gonna get 18. And okay, yes, I'm confident in the 31. So that is our final answer. And now we move rather triumphantly to question 25, which, as you might suspect, is in the next video. So thanks for watching, and I'll see you guys next time.